Okay, let's basically discuss the duality property of the Fourier transform, and I show you that if you have a pair, a Fourier pair, x and capital X of omega, you can get another one for free by simply taking x of omega and making it a function of the time, and then the correspondent Fourier transform is 2 pi x of minus omega. So this is one Fourier pair for free. Let's prove this, and the derivation is very simple because we need to let's remember what are the definition of Fourier transform and inverse Fourier transform. This is equal to the integral minus infinity plus infinity x of t e to the minus j omega t. So we want to prove this result. And this is the definition of Fourier transform. What about the anti-Fourier transform? This is also easy because it's 1 over 2 pi integral minus infinity to infinity capital X of omega e to the minus j omega t in the omega. Now, as you can see, this integral here resemble this other integral here, is right? Actually, now we can do some substitution and manipulation of this integral and make it to look like this one. Okay? First of all, for example, we can take this 2 pi and bring it on this other side. Okay? And actually I made a mistake here, it's plus. Then what we can do? Let's rewrite this exponential as e to the minus j omega minus t. Nothing changes, right? Minus and minus plus, I still get the same expression. So now you can see that this integral can be written as 2 pi x of small x of t, the signal, equal integral minus infinity to infinity capital X of omega e to the minus j omega times minus t in the omega. Okay? And now this looks almost like this, almost. We just have to, we now do relabel the variables. So basically, what does it mean? Switch omega with time. If we do that, what do we get? We get that t become omega, so we get, let me do it in blue, we get 2 pi x of omega equal, so this becomes omega, this become t, these become t, these become minus omega, and these basically become t. And we have 2 pi x of omega integral minus infinity to infinity of capital X of t e to the minus j t minus omega in delta t. Very simple. And that is the main result, because, as you can see, now we can see a correspondence here. We need to be careful with this minus omega. So what does it mean? It means that actually this function is 2 pi x of minus omega. It's computed at minus omega, so there is a flip of the signal x with respect to the origin. And actually that is the main results that allow you to prove the duality, because we found the following. I can write the direct Fourier transform as the integral minus infinity to infinity x of t e to the minus j omega t in delta t. This is the direct Fourier transform. And then we were able to rewrite the inverse Fourier transform we rewrite it as 2 pi x of minus omega equal integral minus infinity to infinity x capital X of t e to the minus j minus omega t in delta t. And now we have almost proved everything, because we know that at xt, if I have a signal xt, the correspondent Fourier transform is going to be capital X of omega. But then these results is also telling me that if I have a signal which is the Fourier transform but written in the time domain, the correspondent Fourier transform is going to be equal to 2 pi x of minus omega. And that's it.